In this video, we are going to talk about area between two curves. Let us consider two curves y equal to f of x and y equal to g of x with the condition f of x should be greater than or equal to g of x over an interval a comma b, where a is the lower limit, b is the upper limit. Then the area of the region bounded by the curves from x equal to a to x equal to b is given by capital A is equal to the absolute value of integral a to b f of x minus g of x with the condition f of x greater than or equal to g of x into dx. Let us see question number 1. Find the area bounded by the two curves y equal to 3 minus x and the other curve is y equal to x squared minus 9. Since I don't know anything about the point of intersection, we have to solve both equations. If you see both equations, the left hand side values are same. In the first equation also we have y, in the second equation also we have y. So I can equate the right hand side of both of the equations. So that will be 3 minus x is equal to x power 2 minus 9. By rearranging the terms, we will get x power 2 plus x minus 12 equal to 0. By factoring this, we will get x minus 3, x plus 4 equal to 0. So that means we have x equal to plus 3 and x equal to minus 4. So now we can write the formula. So a equal to integral minus 4 to 3. Remember, whenever you are using integration, the lower limit always a small number compare with the upper limit. Then we have f of x minus g of x. F of x is my first function. So here we have 3 minus x minus of g of x, which is x squared minus 9 times dx. Okay, so this will be minus 4 to 3, 3 minus x. By distributing minus over here, we will get minus x power 2 minus minus plus 9 times dx. Or I can say minus 4 to 3 minus x power 2 minus x plus 12 equal to into dx. By integrating this, we will get minus x power 3 by 3 minus x power 2 by 2 plus 12x between minus 4 and 3. Then substitute upper limit minus substitute lower limit, that will give you 343 by 6 square units. Question number 2. Find the area bounded by the curves 2x power 2 plus y minus 7 equal to 0 and x power 2 minus y plus 4 equal to 0. So once again, we have to equate both results. Before that, from the first equation, keep y on the left side, take the other terms to the right side. So that will give you minus 2x power 2 plus 7. Do the same thing for equation number 2. Keep y on the left side and take the other terms on the right side. That will give you x squared plus 4. Now, like I said in the previous problem, in both of the equations, we have the left hand side values are same. So let me equate the right hand side value. That means minus 2x power 2 plus 7 is equal to x power 2 plus 4. By rearranging this, I will get minus 3x power 2 equal to minus 3. Cancel minus 3 on both sides, we will get x squared equal to 1. That means x equal to plus 1 and minus 1. So we have minus 1 to 1. Write the first function f of x minus write the second function g of x. Integrate between minus 1 to 1. We will get a equal to 4 square units. Question number 3. Find the area enclosed by the curve x equal to y squared minus 5y plus 4 and the y-axis and y equal to 0 and y equal to 2. So here we will write the area as The given values are 0 to 2 x times dy, because here in this problem the function is given in terms of x in terms of y. So we have to use the formula x into dy, or I can say f of y into dy. Okay. To check the limits, we are going to set x value equal to 0. If I set x equal to 0, we will get minus y power 2 minus y plus 4 equal to 0. By factoring this, I will get y minus 1, y minus 4 equal to 0. That means y equal to 1 and y equal to 4. So we have like this, y equal to, the values are 1 and 4. But what is the value given in the problem? Y equal to 0 to 2. So 0 lies outside the interval, and here we have 2. So this I can split into two parts. This 4 also not included in the region. So here my given limits are 0 to 2. So between 0 to 2, I have to check these two values are inside or outside. So we have 0 and we have 2. So 1 should be here, but 4 should be outside of the region. So we have to consider only this region. But this region we have to split into two parts, starting from 0 to 1 and starting from 1 to 2. So we are going to calculate two area of region, A1 and A2. So A1 starting from 0 to 1. A2 starting from 1 to 2. So this is my first integration, A1 0 to 1 f of y dy. What is f of y? Which is nothing but the given function. What is the function? Y power 2 minus 5y plus 4. So integration of y power 2 will give you y power 3 by 3. Integration of minus 5y will give you minus 5 y power 2 by 2. Integration of plus 4 will give you plus 4y. Then we have to substitute upper limit 1, lower limit 0. If I put lower limit 0, everything gets 0. If I put upper limit 1, we will get 1 by 3 minus 5 by 2 plus 4. By simplifying this, I will get A1. The first region of the integration will be 1.75. Let us move to second region, A2. For A2, we have to start from the limit 1 until 2. So we have A2 equal to integral 1 to 2 f of y dy. Again, take the same function, y power 2 minus 5y plus 4. Integrate every term with respect to y. Then substitute upper limit 2 minus substitute lower limit 1. You will get this one. By simplifying this, I will get minus 1.083. So what is my area now? My area A equal to the addition of the two integrals A1 plus A2. So this is A1 value, this is A2 value. Since we are looking for area, we always look for positive value. So take the absolute value of this one. That means this minus sign will get ruled out. Then we have 1.75 plus 1.083. By adding this, we will get 2.833 square units. Let us discuss one more question. Here the curve is y equal to x power 2 minus 3x enclosed by x-axis and the value x equal to 1, x equal to 5. Previous question we have set x equal to 0 because previous question the problem is given in terms of x. But now the problem is in terms of y. So y is a function. So what I do? I have to set y value equal to 0. What is y value here? My y value is x power 2 minus 3x, that is equal to 0. Taking x as a common factor, we have x minus 3 equal to 0. So I have two options, x equal to 0 and x equal to 3. But what is the given limits, given region? X equal to 1 and x equal to 5. So what are the two values which I got? X equal to 0 and x equal to 3. So definitely 0 lies outside the segment. and x equal to 3 lies inside the segment. So like previous problem, this we have to divide into two parts. First part A1, second part A2. For A1, the region of integration will be integral 1 to 3. For A2, the region will be 3 to 5. So first we will calculate A1 between 1 to 3 y into dx. So 1 to 3 y into dx. So that means 1 to 3, what is y value? X squared minus 3x into dx. Integration of x power 2 is x power 3 by 3 minus 3 is a constant term. Integration of x will give you x squared by 2 between 1 to 3. By substituting upper limit, this will give you 3 to the power 3 by 3 minus 3 times 3 to the power 2 divided by 2. Then minus, I have to substitute lower limit. The lower limit is 1, 1 power 3 is 1, so we have 1 by 3 minus 3 by 2. By simplifying this, you will get minus 3.3. Then I have to consider the second region of integration. My second region of integration is starting from 3 to 5. So we have 3 to 5, same function y. My function is x squared minus 3x into dx. Integration of this will give you x power 3 by 3 minus 3x squared by 2 between the limits 3 and 5. First substitute upper limits. So we'll give you 125 by 3 minus 3 times 25, which is 75 by 2. Then minus lower limit 3 power 3, which is 27, 27 by 3, which is 9, minus 3 power 2, 9, 9 times 3, 27, which is 27 by 2. By simplifying this, you will get 8.67. Okay, so what is the final answer? The final answer is addition of region 1 and region number 2. What is region number 1? My region number 1 is A1 plus what is region number 2? A2. Remember, since we are calculating area, absolute value of A1 plus absolute value of A2. So here absolute value of A1 will be minus 3.33 plus absolute value of 8.67. So we have to rule out the minus sign. So we have just taken 3.33 plus here no minus sign. So just take the value as it is, 8.67. By addition of these two will give you 11.99 square units. These two problems we will leave you as a homework problem. Try yourself. See you in the next video.